DynIBaR, developed by Zhengqi Li, is an AI model that transforms regular 2D video clips into 3D versions, enabling various scene-dependent edits such as focus adjustments, animated camera positions, stabilization, stereo 3D conversion, and potential relighting. The research introduces DynIBaR as a neural dynamic image-based rendering technique, focusing on the challenge of synthesizing novel views from monocular videos depicting complex dynamic scenes, which existing methods struggle to achieve. By adopting a volumetric image-based rendering framework and leveraging motion trajectory fields and a new temporal photometric loss, DynIBaR significantly improves rendering fidelity for both static and dynamic scene content. It offers scalability to long videos with complex motion, overcoming limitations of prior methods, and facilitates motion-aware feature aggregation, enabling accurate representation of spatio-temporally varying geometry and appearance. Moreover, DynIBaR demonstrates its effectiveness in producing high-quality renderings for challenging real-world scenarios, particularly in the wild videos with long duration, complex scene motion, and uncontrolled camera trajectories, outperforming previous methods. In summary, DynIBaR presents an innovative approach to dynamic image-based rendering, addressing limitations of existing methods. With its scalability and enhanced rendering fidelity, DynIBaR contributes to the advancement of dynamic view synthesis methods in real-world applications. With its scalability and enhanced rendering fidelity, DynIBaR contributes to the advancement of dynamic view synthesis methods in real-world applications. We hope you are as excited about this AI innovation as we are. Remember to hit that subscribe button to stay updated on all our upcoming explorations. Thank you for joining us, and we will see you next time with more mind-blowing AI discoveries.